Welcome to this in-depth technical analysis of electrical wiring diagrams. In this presentation, we will dissect the components, flow, and interpretation of schematic representations used in electrical engineering and industrial automation. If you're an aspiring electrical engineer, technician, or electrician, mastering this skill is paramount. An electrical wiring diagram is a graphical representation of an electrical circuit. It depicts the interconnection of components using standardized symbols, enabling engineers and technicians to design, troubleshoot, and analyze electrical systems with precision. These diagrams ensure compliance with regulatory standards and facilitate systematic diagnostics. Wiring diagrams serve as the foundational blueprint for electrical system implementation. They provide critical insights into circuit behavior, component placement, and interconnectivity, ensuring that installations are executed with accuracy. Without them, diagnosing faults and performing maintenance would be inefficient and error-prone. Electrical diagrams are categorized based on their purpose and level of detail. Wiring diagrams illustrate real-world component placement, whereas schematics emphasize logical circuit functionality. One-line diagrams streamline power distribution representation, while block diagrams provide a high-level view of system functionality. Each wiring diagram includes a legend that serves as a reference for symbol interpretation. This key defines electrical symbols, line types, conductor specifications, and component designations, ensuring uniform comprehension across engineering disciplines. Electrical schematics adhere to global standardization protocols such as ANSI, American National Standards Institute, and IEC, International Electrotechnical Commission. These standards define universal graphical representations for electrical components, ensuring consistency across industrial, commercial, and residential applications. Interconnections within wiring diagrams are represented by conductive paths. Solid lines denote continuous conductors, while dashed lines indicate optional or hidden wiring paths. Junctions where conductors intersect are marked with connection nodes, whereas non-connected crossovers are depicted without nodes to prevent misinterpretation. Wiring diagrams adhere to logical directional flow principles, where energy transmission follows a defined path from power sources to loads. Standard conventions dictate left-to-right or top-to-bottom orientation, streamlining analysis and component tracing. A fundamental wiring diagram consists of a power source, switching mechanism, and load. This elementary example illustrates how an SPSD, single-pole, single-throw, switch governs current flow to an incandescent lamp. A crucial aspect of diagram interpretation is identifying the power source. Electrical systems operate on either alternating current, AC, or direct current, DC, each requiring specific design considerations, protective devices, and circuit configurations. Loads convert electrical energy into mechanical, thermal, or optical outputs. Common loads include motors, resistive heating elements, solenoids, and indicator lamps. Proper load identification ensures precise circuit functionality assessment. Control elements such as push-button switches, relays, and contactors modulate circuit operation. These components dictate electrical state transitions based on input conditions and logic sequencing. This wiring diagram represents a basic motor control circuit incorporating a start/stop push-button station, contactor, and overload relay. Understanding these elements enables engineers to troubleshoot motor operations effectively. Technicians leverage wiring diagrams for fault diagnosis by tracing signal paths, measuring continuity, and verifying voltage levels. Systematic troubleshooting minimizes downtime and enhances electrical system reliability. Adherence to electrical safety protocols is imperative. Always de-energize circuits before performing maintenance, verify insulation integrity, and comply with OSHA, Occupational Safety and Health Administration, or IEC regulations. Wiring diagrams are extensively utilized across industries, from residential installations to advanced industrial automation systems and automotive control networks. Advanced analysis techniques involve tracing power sequences, isolating control circuits, and understanding feedback mechanisms to optimize system performance. Test your comprehension. What happens when a normally closed NC switch is actuated? Comment below with your answer. To summarize, mastering wiring diagrams requires symbol recognition, directional flow analysis, and methodical troubleshooting approaches. For more technical insights, subscribe to the channel and enable notifications to stay informed on electrical engineering and automation principles.